Welcome to the Code Navigators, the program that's all about helping you master the International Code Council codebooks.
That's right. If you're out there studying, especially getting ready for those big ICC certification exams, we want this to be your go-to resource.
We're going to walk through the codebook chapter by chapter and really break down not just what's in it, but how to find what you need and fast.
Today, we are tackling a big one, a really fundamental part of the 2021 International Building Code, Chapter 10, Means of Egress.
And before we dive in, a quick word on how we put this together. We do use AI to help with generation, but, and this is important, everything is produced and double-checked by a human code professional. We want to make sure you're getting accurate, properly contextualized information.
Absolutely. And that leads us to our most important point, something we have to say right at the top.
The legal disclaimer.
Yep. Please remember, this program is for educational purposes only. It is not professional advice. It can't, under any circumstance, replace the official code documents.
We really can't stress that enough. You always have to consult the official, current edition of the code and talk to a qualified design professional or a building official for any real-world project.
We're here to help you study the concepts. We are not stating any copyrighted material from the code verbatim.
Okay, with that very necessary foundation laid, let's jump into Chapter 10.
Means of egress. At its core, it's pretty simple, right? It's the system designed to get people from wherever they are in a building to a place of safety, the public way.
And it does that in a timely, predictable manner. The system has three parts: the exit access, the exit itself, and the exit discharge.
Exactly. And what you see right away is how this chapter is kind of the central nervous system of building safety.
It's so heavily cross-referenced. You can't talk about egress without talking about fire protection from Chapter 9 or interior finishes from Chapter 8.
And it's constantly interacting with all the special use and occupancy rules later in the book. It's complex because the basic rules are always being modified.
Right, you have these baseline requirements, and then you have special allowances for, say, an assembly space or unique rules for residential buildings.
Precisely. So to really get a handle on Chapter 10, you have to first understand the general rules, which are mostly in the beginning, and then immediately grasp the exceptions that apply to all the unique situations.
Okay, so let's start where the code starts. Section 1001, Administration.
Mm-hmm.
This really sets the stage for the whole system.
It does. Section 1001.1 is the general requirement. It basically says the means of egress system has to be provided for all parts of a building, no exceptions.
And this chapter governs the design, construction, how it's all arranged. Every little piece that makes up that safe path out.
Then you get to 1001.2, which I always think of as the golden rule of egress. Minimum requirements.
The non-negotiable rule.
Exactly. You are forbidden explicitly from reducing the number of exits or the width or the capacity below the minimums set in this chapter. It's a hard line.
And part of that minimum standard is another really specific detail in 1001.2, ceiling height.
Right. The code demands a minimum ceiling height of 7 feet 6 inches. That's 286 millimeters for our listeners using metric.
7.6, why that number specifically? I mean, beyond just not wanting to bump your head.
It's about ensuring people can move quickly and without obstruction, especially in an emergency when you might be carrying something or just moving faster than usual. But, the code is also practical.
So there are exceptions.
Of course. There are exceptions you really need to flag for studying. There are allowances for sloped ceilings for dwelling units, which are covered in Section 1208.2, and a big one, allowances for protruding objects, which we'll get to in a minute in Section 1003.3.
Okay, so moving on to Section 1003, General Means of Egress. This gets into the quality of the path itself.
Yep. 1003.2 is simple but critical. The floor surface has to be slip resistant. I mean, think about evacuating in a wet or smoky condition. That's a huge deal.
Then we hit Section 1003.3 on protruding objects. This is fascinating because it's not just about clearance, it's really about accessibility.
It is. It's about protecting everyone, but especially visually impaired individuals. The rules regulate anything that sticks out from a wall or hangs from the ceiling.
So let's break that down. For stuff hanging from the ceiling like a door closer, it can't reduce the clear height to less than 6 feet 8 inches.
Right. 6'8" is kind of that absolute minimum vertical clearance for walking around.
But then there's the rule for things sticking out from the wall. They can't protrude more than 4 inches, but only within a very specific vertical band.
Yes, between 27 inches and 80 inches above the floor.
Why that very specific range? 27 to 80 inches.
It's a brilliant piece of universal design. The 80-inch top limit, that's your 6'8" again, protects an average person's head and body. The 27-inch bottom limit is there, so a visually impaired person using a cane can detect the obstacle.
Ah, so the cane sweep would pick it up if it's below 27 inches.
Exactly. And if it's above 80 inches, it's above your head. That 27 to 80-inch zone is the real danger zone for hazards you might walk into, so protrusions are really limited there.
That makes so much sense. That context helps those numbers stick. And there's a small exception for handrails, right?
A tiny one. They can stick out 4.5 inches, just a little more than the standard 4 because, they're a necessary and predictable part of the path.
Okay, that brings us to section 1004, occupant load. You said this is arguably the most critical piece of the whole chapter.
Without a doubt, every single calculation that comes after this, how wide the doors are, how many exits you need, it all comes back to this one number.
So let's unpack it. 1004.1 says you have to use the design occupant load to set all your egress requirements.
Yeah.
You're designing the size of the lifeboat, essentially.
That's a great way to put it. And 1004.2 clarifies that you have to account for people coming from other spaces. If
Okay.
people from room B have to walk through room A to get out, you have to add their loads together for room A's exit path.
Common sense, but it has to be spelled out.
It does. Then 1004.3 gives you the basic math. You take the area of the space and you divide it by an occupant load factor from table 1004.5.
And this table is something every code student just has to know.
They do. And the key to using it is understanding the difference between net area and gross area.
Let's clarify that, because it's a huge point of confusion for a lot of people.
It really is. So gross square feet means you're using the entire floor area in your calculation. Walls, closets, hallways, everything. It's used for places like offices where people are spread out.
And net square feet.
Net means you only count the actual usable space. You exclude things like walls, fixed furniture, restrooms, and corridors. It's for high-density areas where you need a more precise count of people in a functional area.
And that distinction makes a huge difference in the final number.
A massive difference. Let's look at a couple of examples from table 1004.5. An assembly area with loose chairs, like a conference hall, that's 7 net square feet per person. Very dense.
Very crowded.
Compare that to a business area, an office, which is 150 gross square feet per person. The code assumes most of that 150 feet is desks and file cabinets, not people.
Let's run through a few more key ones for studying. Daycare.
35 net. Classrooms are 20 net. Again, dense, structured environments.
And a store. Mercantile.
That's 30 gross, because the layout changes all the time. On the other end of the spectrum, you have a warehouse at 500 gross square feet per occupant. Very few people, lots of space. Knowing those factors is it's the core of the exam.
Can you ever have more people than the table suggests?
You can. Section 1004.5.1 allows it, but you have to get it approved by the building official.
And you'd have to prove it's safe.
Right. You'd submit documentation, like a detailed seating plan for a theater, that shows you can safely accommodate that higher number. It moves it from a guess to a hard number.
Okay, so once that occupant load is locked in, we move to section 1005, means of egress sizing.
Yep. 1005.1 just confirms that the size, the width, the capacity is all based on that occupant load number we just figured out.
1005.2 gives us a minimum width, generally 36 inches for egress paths, unless another section specifies something different.
And then we get to the technical heart of it in 1005.3, required capacity. This is where we calculate the actual width needed.
Let's talk about these capacity factors, because this is a big one. Section 1005.3.1 is for stairways.
For stairs, the standard calculation is you multiply your occupant load by 0.3 inches per person.
Okay, 0.3 inches per person for stairs. What about everything else? Doors, corridors.
That's in 1005.3.2. For all other egress components, it's 0.2 inches per person.
So 0.3 for stairs, 0.2 for everything else. Why the difference?
It's pure safety logic. Stairs are bottlenecks. People move slower on them. There's a higher risk of falling. They're just less efficient for moving people.
So the code penalizes them. It forces you to make them wider for the same number of people.
Exactly. 50% wider, in fact. It's a fantastic way to think about the built-in risk factor.
And of course, there's a reduction if you have fire safety system.
Of course. If the building has an automatic sprinkler system and an emergency voice alarm, that stairway factor drops from 0.3 down to 0.2.
And for the other components, the corridors and doors.
With those same systems, it drops from 0.2 down to 0.15.
So the sprinklers and alarms are basically buying you time.
That's it, exactly. They control the fire, which gives people more time to get out so the path can be a little narrower. The key for your studies is just knowing those four factors: point 0.3, 0.2, point 0.2, and 0.15.
Okay, so now we know how many people we have and how wide the path needs to be. Next up is planning the actual path. Section 1006, number of exits.
Right. Section 1006.2 starts us off. Every single room has to have a direct way out, either to an exit or an exit access doorway. You can't trap people.
And 1006.2.1 ties the number of exits directly to our occupant load. This is where table 1006.2.1 comes in.
Yeah, and the numbers here escalate fast. Generally up to 49 people, you can get away with one exit, but as soon as you hit 50, you need two. From 500 to 1 to 1,000, you need 3, and over 1,000, you need 4.
The more people, the more redundancy you need. Simple as that.
Simple as that. Now, there are some exceptions for low occupancy spaces, but the 2-exit rule for 50 or more people is a big one to remember.
And that's for a single space. Section 1006.3 looks at the whole story, the whole floor.
Correct. You have to calculate the total occupant load for the entire floor and provide enough exits for everyone. The numbers in table 1006.3.2 are pretty much the same. 1 to 500 people needs 2 exits, 501 to 1,000 needs 3, and so on.
This leads us to 1006.3.4, which is all about when you can have a single exit for an entire story.
Which is pretty rare, and it's usually for residential buildings like R2 or R3, or for other occupancies, you can use table 1006.3.42.
Let's look at that for, say, a business on the first floor.
For a group B on the first floor, if you have 49 or fewer people, you can have one exit. But, and this is a big but, your travel distance is capped at 75 feet.
It's risk management. One way out, it's got to be a short and quick path.
Exactly. Which brings us right to Section 1007, exit separation. We have our multiple exits. Now we need to make sure they're far enough apart.
So a single fire can't take them both out.
That's the whole point. And 1007.2 gives us the famous 1/2 diagonal rule. The distance between 2 exits has to be at least half the diagonal measurement of the area they serve.
But, and this is a recurring theme, there's an exception for sprinklers.
There is. If the building has a full automatic sprinkler system, you can reduce that separation to 1/3 the diagonal.
Why is that? Okay, why is closer acceptable with the sprinklers?
It's that buying time concept again. The sprinklers will control the fire at one exit long enough to keep the other closer exit viable for people to escape. The active system makes up for the reduced physical distance.
And if you have 3 or more exits?
Then at least 2 of them have to meet that half or third diagonal rule, and all of them have to be, as the code says, reasonably remote from each other. You just have to spread them out.
Okay, moving on to Section 1008. Illumination. Got to be able to see where you're going.
1008.1 says the lights have to be on anytime the building is occupied. Simple.
And 1008.2 gives us the minimum light level, 1-foot candle at the walking surface, which isn't very bright, but it's enough.
Right. But the critical part is 1008.3, emergency power. If you're required to have 2 or more exits, which is most buildings,
The lights have to be on a backup system.
they do. And 1008.3.4 specifies for how long. The emergency power has to keep those lights on for at least 90 minutes.
Why 90 minutes specifically?
It's calculated to be long enough for everyone to get out, and then for the fire department to arrive and begin search and rescue operations in what might be a dark, smoky building. It's a margin of safety for the first responders.
And now we get to a really important topic, making sure egress works for everybody. Section 1009, accessible means of egress.
Yeah, this is huge. 1009.1 says if you have accessible spaces, you must have an accessible means of egress. And that path has to be continuous all the way to the public way.
But stairs aren't accessible, so how does that work?
Well, 1009.3 says you can use stairs, but only if you provide an area of refuge, an AOR.
So that's what those are for. It's a safe waiting area.
It's a temporary protected holding zone where individuals who can't use the stairs can wait for assistance. And for it to work, 1009.7 requires a 2-way communication system.
So they can call for help?
They can call a central control point and let them know they're there. That whole system, the AOR and the communication, is how the code solves the vertical evacuation problem for non-ambulatory people.
Okay, that covers the planning. Now let's get into the weeds with the actual components. Part 3, starting with Section 1010, doors, gates, and turnstiles.
Here we go. 10.1.1, size of doors, minimum clear width of 32 inches, and minimum clear height of 80 inches, which is 6'8".
That 32-inch clear width, that's for wheelchair access, right?
It is. It's a standard across the board. Then 10.1.3 limits how far hardware can project into that opening, usually to 4 inches.
And 10.1.5 says a landing has to be as wide as the door it serves. Can't have a narrow path leading to a wide door.
No, you can't. Then 10.2 gets into door operations. This is where the rubber meets the road. Doors have to be easy to open, no keys, no special knowledge.
The single motion unlatching rule, one push and you're out.
Exactly. Now, there are some exceptions for key-operated locks in 10.2.6, but they're for low-risk, low-occupancy places, and they have a lot of conditions.
But one hard and fast rule, 10.2.7 says you can never lock a stairway discharge door from the inside.
Never. Once you're in that protected stairwell, you have to be able to get out at the bottom.
And for crowded places, 10.2.9 requires panic hardware.
Right. For assembly or education occupancies with 50 or more people, or any high-hazard group H, that's the big push bar that opens the door no matter what.
What about those doors in stores that buzz and don't open right away?
Delayed egress, that's in 10.2.13. The delay can't be more than 15 seconds, and the lock has to release instantly if the fire alarm or sprinklers go off, and there has to be a sign explaining it. It's security balanced with safety, but safety always wins.
Okay, what about revolving doors?
Section 10.3. They have speed limits, and here's the key. They can't account for more than half of your required exit width. You always need regular swinging doors next to them.
Same rule for turnstiles in Section 10.5.
Basically, yes. No more than 50% credit for your egress capacity. You need a full-width gate right next to it.
All right, Section 10.11, stairways. You said this is a goldmine of numbers for exams.
It is. Let's nail the big ones. 10.11.5. Riser height and tread depth. Maximum riser height is 7 inches. Minimum tread depth is 11 inches.
7 and 11. That ratio is designed for safety, to prevent tripping.
It is. And the nosing, the little lip that hangs over, can't project more than 1.25 inches.
And landings. Section 10.11.6.
You need them at the top and bottom, and you need an intermediate landing if the stair goes up more than 12 feet vertically.
Why 12 feet?
It's a safety brake. It limits how far you can fall in one go, and it gives people a place to rest. It just makes a long flight of stairs much safer.
And the landing has to be as wide as the stairs.
Got other.
What about ramps in Section 10.12?
Ramps are the accessible alternative. The key number in 12.2 is the slope. Maximum slope is 1 vertical unit for every 12 horizontal units, 1 in 12.
8.33%. Any steeper is too hard to navigate in a wheelchair.
Exactly. And 10.12.4 says you can only go up 30 inches vertically before you need a landing.
Okay, quick hits on the next few. Section 10.13, exit signs.
Gotta have them. Gotta be able to see them. 10.13.3 says they have to be lit, and 10.13.6.3 says they need to be on that 90-minute emergency power.
Section 10.14, handrails.
The height is critical. Between 34 and 38 inches high, that's the sweet spot for grabbing. And there are specific rules for the shape, whether it's a circular type 1 or a non-circular type 2.
And finally, Section 10.15, guards. These are the fall protection barriers.
Right. Required anytime you have a walking surface that's more than 30 inches above the floor below. 30 inches is where a fall starts to get really serious.
And this is where we get the 4-inch sphere rule, right, in 10.15.4.
That's the one. Openings in the guard can't let a 4-inch sphere pass through. It's a child safety rule to prevent a small child's head from getting stuck.
With one little exception for the triangle at the bottom of the stairs.
Right. That little triangle by the tread can be a bit bigger, allowing a 6-inch sphere just because of the geometry of how stairs are built.
Okay, we've defined all the pieces. Now let's put them together in the travel path. Part 4, starting with Section 10.16, exit access.
Right. So this is the path from wherever you are to the door of a protected exit. And 10.16.1 says it has to be clear and unobstructed.
But 10.16.2 puts some limits on what you can walk through. You can't just egress through any old room.
No, you can't. The code really wants to avoid having people navigate through, say, a kitchen or a storage room or a factory floor to get out. It's too unpredictable, too hazardous.
So the path has to feel like a dedicated, safe corridor.
That's the idea, and that leads directly to Section 10.17, exit access travel distance, how far you're allowed to walk to get to safety.
And this is another one of those things where the numbers are critical for exams, and they live in Table 10.17.2.
They do, and you can really see the code's risk assessment here. The distance changes based on what the building is used for, and you guessed it, whether it has sprinklers.
Let's see an example. For a standard office, Group B.
For a Group B without sprinklers, your max travel distance is 200 feet. But with sprinklers, it jumps all the way to 300 feet.
That's a huge difference.
It is. For a lower hazard warehouse, it's even bigger. 300 feet without sprinklers, 400 feet with them. The code is willing to let you walk further if it knows an active system is controlling the fire.
Okay, so a big part of that path is often a corridor. Section 1020 is all about corridors.
And 1020.2 says they often have to be fire rated. If a corridor serves more than 30 people in most buildings, it needs at least a 1-hour fire resistance rating. It's like a protected artery leading to the exit.
And the width in 1020.3 is usually 44 inches minimum, but it can be much wider in hospitals where you need to move beds.
Right. And then 1020.5 deals with dead ends, a corridor where you can only go one way.
The dreaded dead end. The limit is 20 feet.
20 feet. That's how far the code thinks you can walk before you realize you're trapped and can still safely turn back. But with sprinklers, it's extended to 50 feet. Again, the sprinklers control the fire at the entrance to the corridor, giving you time to get out of that 50-foot trap.
All right, so we've traveled down the exit access path, and now we arrive at the exit itself, sections 1022 through 1024.
1022.1 just defines an exit. It's the protected part of the system that gets you from the access to the discharge.
And section 1023 is all about those protected stairways and ramps, the vertical exits.
The key here is the fire-rated enclosure. 1023.2 says if the stair connects 4 or more stories, it needs a 2-hour rating. Less than 4 stories, it needs a 1-hour rating.
More stories, more time needed to evacuate, so a tougher enclosure.
Exactly. And that enclosure has to take you all the way to the outside or to an exit passageway, which is covered in section 1024.
Which is basically a protected corridor on the ground floor.
Yep. It's a fire-rated tunnel, usually 2 hours, that connects the bottom of a stairwell to the exterior door, keeping you safe all the way out.
Okay, we've covered the main system. Let's finish up with some specialty systems and the final destination. Part 5, starting with section 1025, luminous egress path markings.
This is your glow-in-the-dark tape, and it's required specifically in high-rise buildings.
Buildings over 75 feet tall. Why 75 feet? That seems like such a random number.
It's not random at all. 75 feet is the traditional maximum reach of a fire department's aerial ladder truck.
Ah, so above 75 feet, firefighters can't rescue you from the outside. They have to come up the stairs.
Exactly. So if the power goes out in a smoky stairwell, these luminous markings are absolutely critical for guiding both you and the firefighters. They mark the steps, the landings, the door handles, everything you need to feel your way out.
That's a great piece of context. Okay, section 126, horizontal exits. This is when you exit sideways.
Pretty much. You go through a massive firewall into an adjacent, separate, safe part of the building. It's another building, effectively. That safe area is your refuge area.
But you can't rely on them completely.
No, they can only count for half of your required exit capacity. You still need traditional stairs. And that refuge area has to be big enough. The calculation in 1026.4 requires 6 net square feet per person. It's going to be crowded, but safe.
So after all that, we finally make it outside. The exit discharge, section 128.
The final stop. 1028.1 says exits have to discharge you directly to the exterior, to a public way.
Or to an egress court from section 129.
Which is basically a protected courtyard or walkway that connects the building's exit door to the public street when the building isn't right on the sidewalk.
Okay, 2 big specialty sections left. Section 1030, assembly seating. This is for theaters, stadiums.
Places with lots of people who don't know the layout and are packed in tight. The risk of panic is much higher, so the rules are much stricter.
It's a whole different ballgame.
It is. The aisle capacity calculations in 1030.6 are more complex. The travel distances in 1030.7 are tighter, and the aisle widths in 1030.9 are wider. A stepped aisle serving more than 50 people needs to be 48 inches wide, not the standard 44.
It's all about moving a large, panicked crowd as efficiently as possible.
That's the whole game. And our final section, 1031, emergency escape and rescue.
The classic bedroom escape window.
That's it. Required in basements and sleeping rooms in most residential buildings. 1031.2 gives the minimum size, 5.7 square feet of clear opening.
Which is big enough for a person to get out and a firefighter in full gear to get in.
Exactly. And 1031.3 gives the minimum dimensions, at least 20 inches wide and at least 24 inches high.
And if it opens into a window well, section 1031.5 says if that well is deeper than 44 inches, you need a ladder or steps built into it.
Right. 44 inches is about the height where it becomes difficult to climb out unassisted.
Wow. That was an exhaustive look at Chapter 10. We went from the big picture philosophy of occupant load all the way down to the 4-inch sphere rule for guards.
It's a huge chapter, and it's so easy to get lost in the numbers when you're studying for an exam, but I think if you can tie it all back to one single principle, it makes a lot more sense.
And that principle is?
Continuity. Every single rule in this chapter is about creating a continuous, unbroken, protected path from wherever you are to the outside world.
That's the ultimate takeaway.
I think so. Why does the door have to be 32 inches clear? Continuity. Why do you need luminous markings in a high-rise? Continuity. Why can you have a longer travel distance with sprinklers? Because the sprinklers ensure the continuity of that path's safety for a longer period of time.
Viewing it that way,
Yeah.
as one long connected system, makes all the individual rules click into place.
It does, and it raises a final question for you to think about as you study. We've seen how much the code relies on active systems like sprinklers to relax the requirements for passive physical components like walls and distances.
Right.
So what does that imply about the importance of maintaining those active systems? If your safety depends on them working perfectly, how does that change how you view the long-term inspection and testing requirements for those systems?
That's a great thought to chew on. Well, thank you for joining us on this tour of IBC Chapter 10.
Our pleasure. If you found this helpful and you want to support what we do here, you can find our Patreon link in the show description. We'd really appreciate it.
Thanks for tuning in. We'll see you on the next journey through the code book.